Oops. Okay. So today in Algebra 2, we are still in Unit 1. So I'm just going to title my notes here. And today is day 6, I believe. Yes, day 6. So these will be our day 6 notes. And pause. And today is Tuesday, August 12th. I know, Mondays are hard. We're getting in the groove. Now it's Tuesday. Tuesday's like another Monday sometimes, though. Okay, so this will be page 1. All right. So, we have been learning all about quadratic equations, how to solve for x in a quadratic equation. But now I want us to get a little bit more into what the graph of a quadratic equation looks like. So, I am going to title this, let's see, Parabolas, P-A-R-A-B-O-L-A-S. There's a lot of big math words. You get to know them one day. So, parabolas. A parabola is just a fancy word for the graph of a quadratic equation. So I'm going to write that definition here. The graph of a quadratic equation. Okay. And let me grab my note page for what we're going to look at. What I would like for each of you to do is now we're going to take out one of those notes that is a graph. And you're going to stick one on your notes. And I'm going to give you a guide of what to draw on this. So first, before we ever graph anything, we need an x-axis and a y-axis. So I'm going to start with my arrows. And I will connect those with my ruler. Like that. And like this. Okay. Now I'm going to, I'll wait a second to zoom in case anyone is still writing that definition. And on my graph, I'm just going to put some tick marks all along both of the axes that we just drew. And I know it's really tiny, but I'm going to try to put some numbers on here. So let's see if this works. Okay, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6. 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay. So, not a work of art, but it will work. Once you've got that, we're going to label our x-axis and our y-axis. Now, which one is the x-axis?
Sideways.
Sideways, from left to right. That is the x-axis. So the y-axis goes up and down. Okay. Now, once you've done that, I'm going to give you a couple of points. And whenever you draw your points on the graph, I want you to be very careful to put them right where I tell you to. So, the first point, we're going to put it at, let's see, let's do over 4 on the x-axis, down negative 3 on the y-axis, so right here. And I will label that. That is 4, negative 3. There's my first point. And once you've drawn that first point, we're going to make a dotted line going straight up and down through that point. So here's how I'm going to do that. My point is here. I'll start making dotted lines above it and below it. Just like that. So this dotted line should be going through the number 4 on the x-axis. And if we want, we can even label this line x equals 4. X equals 4, because no matter where you are on this line, the x value is 4.
Is it the axis of serenity?
Axis of symmetry. Very close, yes, yes. Serenity. I like that. Okay, so we have an axis. Now, once you've done that, we're going to draw 2 more points. On either side of this line, Hygiene, I'm going to start from 4 and move over 1, 2. So this point, yep, it'll be on 6. No, I didn't label this really great. So this coordinate is going to be 6, 0. And then we want to do the same thing on the other side of the dotted line. Go over 1, 2, and make a dot, a point, a coordinate at 2, 0. Yes, 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 yes. So, point here at 2, 0. Okay. I'll let everybody get up to there. All right, now one last point. We're going to also put a point at 6 on the y-axis. Right here. Yeah. And this coordinate can be labeled. What would this coordinate be?
That's the, y-intercept would be 6, 0.
Flip-flop it.
0, 6.
0, 6, good. X value comes first. It lines up with 0 on the x-axis. Y value comes next. 6. Okay, so we should have 1, 2, 3, 4 points on our graph. And a line going up and down through x equals 4. And finally what you're going to do, and it does not have to be perfect, it won't be perfect, we're going to connect these dots. Now, not the way that you normally would, where you would draw a straight line. You're going to make some curved lines here. So, I'm going to start down here at my lowest point, and I'm going to connect it to these points like this. Okay. And once you've done that, we want to connect this one up to here, all the way through. And this is probably not even a real graph, but we're going to do it like this anyway. And then our graph is done. You don't have to put anything else. So we're about to do a bunch of labeling. So I'm going to give us a minute to get this drawn and get us all caught up to here. That really probably should have gone through 7 or 8, but that's okay. All right, now I will pause it for a moment. All right, so what I will do now is just shift this over slightly so that we can still see this really well. And the first thing we're going to write is, yes, direction. So D-I-R-E-C-T-I-O-N. Direction of opening. And your options for that will always be up or down. So next to that, we're going to write up or down. And you know, up is facing up, down is facing down, just like that. Yes. After direction of opening, we're going to write, yes, vertex, V-E-R-T-E-X, vertex. After vertex, axis of symmetry, axis, A-X-I-S, of symmetry, S-Y-M-M-E-T-R-Y. Mm-hmm. Yes, ma'am. The next line is zeros. Z-E-R-O-E-S. Zeros. And then in parentheses, I'm going to write x-intercepts. I-N-T-E-R-C-E-P-T-S. And yes, next we have y intercept. Okay. Now, we're just going to do these today. There's also a domain and range, but we're not going to worry about that today. So I'll let everybody get this copied down. Lots of writing today. I do apologize, but I'll give you time to write. So, first thing, direction of opening. The opening of a parabola is where that, like, you see how it's a U shape? The inside of the U, wherever those arrows are pointing, that's going to tell you the direction. So this is going up. So we're going to just circle up. This graph is going up. And if it helps you, this is the one that I don't think anyone's ever gotten this wrong. Oh, yeah. The arrows are going up, so the direction is up. Now, the vertex. This is going to be either the lowest point on your graph or the highest point. Yes, it depends on which way your graph is facing. This one is facing up, and since there's arrows on the ends of this parabola, it means that it goes up and up and up and up forever and ever, and it never ends. Infinity, yes. So, if it goes up forever, there's no highest point. There's only a lowest point, and that lowest point is your vertex for -3. So, for -3. And you know what? I'm going to do that. What'd you say? Uh-oh, what you lost on? Did you get the picture drawn? Yeah. Okay. Did you get your words here written down? Okay. Is it the vertex that didn't make sense just now?
It does now.
Yeah, so this is another way to think of vertex. Vertex is a V. This is also kind of like a V. It's the bottom of the V. That's your vertex. It's always going to be kind of the pointy part. And it's just whatever the coordinate is. So for -3. Now, the axis of symmetry. Once you know your vertex, this is a trick. It's going to be the same x value as the vertex. Notice, this is your axis of symmetry. Do you know what symmetry means? You ever heard of that word?
Yes.
Symmetrical? Have you heard that word?
Yes.
Yeah, you say like, oh, this is, let me find something symmetrical. Like a square. This square is symmetrical because I can fold it in half and the sides match. It's the same. There's symmetry there. So, hello. This is our axis of symmetry because this is the point where this side is a reflection of that side. So you could open and close this like a book. It's symmetrical. So the axis of symmetry, we label it by writing x equals 4, the number that it goes through. It will also always be the same x value as your vertex every single time. It will never be y, it's always x. Always x. So this is your axis of symmetry. Okay. So next we have zeros, or they can be called x-intercepts. Now the reason that these are called zeros is because, you remember how yesterday I was telling you that when you solve a quadratic equation, let me pull those notes out before I start explaining. That'll make more sense if I show you. So yesterday I was explaining to you how if you solve for x with a quadratic equation, when you plug it back in, your y will equal 0. Your y equals 0 whenever you plug in the answers you get for x. And the answers you get for x sit on the x-axis. So our zeros, or our x-intercepts, are going to be the ones that have zeros for y and that touch the x-axis, these 2 points. So, yes, our x-intercepts are 2, 0 and 6, 0. I would also accept just 2 and 6. So let me write that. Yes, you could do that. You could also say or x equals 2, 6, just like you do whenever you solve the equation.
Yeah.
I would be fine with this. Both are fine. Okay, and I'm going to do a little bit of color labeling just to show where that is on the graph. Our x-intercepts, I'm highlighting that pink, are right here in pink. See that? And then finally our y-intercept. Yeah, the y-intercept is where it touches the y-axis, right here. So you could either put the coordinate 0, 6, or I would accept y equals 6. I would accept either one. So I will leave this up for a moment. Lots of things to write. Let you guys catch up to there. And then we're going to do some practice identifying these things. Okay, so can I move this up a little?
Yeah. Yes.
All right. So, graph paper. We are going to make some parabolas. And before I do that, I'm going to label this page so I know that it's part of my notes for today. Algebra 2, Unit 1. And this is going to be part of my Day 6 notes. For Tuesday, August 12th.
Would this be considered page 2?
Yes. We'll call this page 2. Okay, so I'm going to give you some more points. We will put a point right here down at -4 on the y-axis. And another one at 4 on the x-axis. And -4 on the x-axis. Now, these are the only 3 points I'm giving you. And we'll draw the parabola. Okay, and it does not have to be perfect. Mine is not perfect. We'll call this number 1. So, for this new parabola, what is my direction of opening, up or down? Up. Okay, so we got that. Let's see. Underneath here, I'm going to put direction up. Okay, the next point is the vertex, and don't shout it out. Don't shout it out if you know it. Everybody look for the vertex. Titania, what's my vertex?
-4.
-4, that's the y value. That's okay. So for a vertex, we need an x value and a y value.
4. Would it be 4 and 0?
4 and 0. So here, tell me this first. Where, can you describe without giving me a coordinate, which one of these 3 points would be the vertex? The 2 at the top or the 1 at the bottom?
One at the bottom.
The 1 at the bottom. This is my vertex. So what is the x value of this vertex? Ooh, I hear so many different answers. I hear 4, 0, -4, 0, 0, -4, 0, 4. Let's think about it. To figure out where this lines up on the x-axis, remember the x-axis goes from left to right. So I'm going to trace my finger until I touch the x-axis. 0. So that is my x value. 0. Now, where does it touch the y-axis? -4. Good. So our vertex is 0, -4. Okay. The next thing axis of symmetry, and I'm just going to write SYM to kind of abbreviate. Now the axis of symmetry, are we going to choose an x value or a y value? Look at the notes you just took.
Be a y value. It's wherever the line goes down straight through the vertex.
It will go through the vertex.
Yeah.
It will go straight up and down. Check your notes, though. Check what we just wrote. Is it going to be x equals or y equals?
It's going to be x equals.
X equals. Good. Because we are looking at where it crosses through the x axis. It crosses right here. So I'm going to draw the axis of symmetry. And this one's funky because it's going right through the middle of the graph. Okay? Now, what value is going to match the axis of symmetry with the vertex?
0, right?
0. It's going to be the same number as the x on your vertex. So the axis of symmetry is x equals 0. X equals 0. Okay. So we got that. Next, we have x-intercepts or zeros. And then we have y-intercepts. Okay. Remember, the x-intercepts are where does the parabola touch the x-axis?
-4 and 4.
Yes,
Yeah.
-4, +4.
Doesn't matter which row it is, like, is it okay for numbers to flip, or do they have to be in a certain way?
Very good question. Ella asked, does it matter what order I write these in? No.
Right.
You can do 4 and then -4. You can do -4 and then 4. Either way is fine with me. So remember with these, you can either just write the numbers, x equals -4 and 4, or if we wanted to write them as coordinates,
I think it'd be more good.
this would be what? -4, 0. And this one would be 4, 0. If this is a lot of information. If figuring out all the coordinates stresses you out, -4 and 4 is fine. But do not put that in parentheses, because this is not a coordinate. Okay? Now we have one last thing to look for, the y-intercept.
Would be -4.
Ah, yeah, so this is a special case where the y-intercept is the same as the vertex, because the y-intercept is just where does it touch the y-axis, and it touches right here at -4. So you can either say y equals -4, or you could write a coordinate 0, -4. Okay. Lots of information here. Lots of information.
I kind of watch those YouTube videos.
And that definitely helps to kind of watch videos and stuff.
Is that all we're doing today?
I mean, we're doing a couple of things today. We're doing a couple of things. Okay.
I might not be here for the second one.
Okay. All right. Now, do we have any questions about what we just put on this paper? Okay. Okay. Let's do another one. Can I move this? Anybody, if you still need it, I can wait. Can I move it? Okay. Another one. This time we're going to put a point up here at -3, 5. And another one here at -1, 0. One here at -5, 0. And then one here at 0, -5. Yeah. And we'll connect these dots. Okay. So, new parabola. Number 2. Okay. And maybe I'll do some of the labels over here. Direction, vertex, axis of symmetry, x-intercepts, y-intercepts. Okay. What direction does this parabola open, up or down? Down. This one points down. So I'm going to write down this time. Okay. Now this time is my vertex going to be the lowest point Or the highest point. Because since our graph is pointing down, there's no lowest point. It goes down for infinity. The highest point will be our vertex. Now, what is this vertex? What's the coordinates of this point?
-3, 5.
-3, 5. Here we go.
Yeah. It's the dot that touches. It's the coordinates going up and then this one over.
Now, if you remember the trick for the axis of symmetry, it's going to match the x of the vertex. So, our axis of symmetry should be what?
-3.
Yes, x equals -3. And we want to draw that as well. Here's -3 on the x-axis. And sure enough, it goes right through the middle. Just like that. Okay. Can anybody raise their hand and tell me one or both of the x-intercepts next? Somebody be brave. I know you got it, girl. X-intercepts. Does anybody want to take a shot at that? Jessica? -5, 0. Yes, that is the first point, the first coordinate.
And would the second one be -1, 0?
Yes, right here. So I'll label these -5, 0 and -1, 0. And over here for x-intercepts, I am completely fine, again, if you just write -5, -1. Even if you don't put the x equals, just the numbers is fine. That's fine with me. Okay. Now, what about the y-intercept? Y-intercept. Where does Rhonda?
-6.
Very close. There's -6.
Oh, -5.
Yeah, my point is on, I know, it's kind of hard to see. -5.
And 0.
So if I wanted to write this as a coordinate, remember this is the y value.
So you do
0,
0 first.
-5. And for your answer right here, you can just put -5 if you want. And I'm happy with that. Okay. This is all you'll have to do on your quiz is just fill, this will already be drawn. You will just have to say up or down. The only coordinate you have to give me is the vertex. Everything else you can just give me numbers. Okay? So, there's our second parabola. And, it must be raining.
Are you serious?
Yeah, that's why I got,
That's so
That rain
crazy.
came out of nowhere.
Right, it was,
Where my phone was.
That's how I did the other night when I was like, it sounds like rain outside. It was
Right.
raining when we went on our break.
that's crazy.
Yeah.
Now, did it rain last night?
I didn't even know it rained last night.
This was so confusing. This morning, I got out of my garage and was going to my car, and my fiance and I are parked right next to each other. My car was soaking wet and his was bone dry.
Cause it was probably raining on one side and not on the other one.
I guess, but they're like this close.
Yeah. Cause I'm gonna tell you a weird
I
story.
didn't understand it. Okay.
It's been a few years ago. We was sitting in my grandma's house. We was playing cards, and we just heard thunder and lightning. We looked out the back door. It wasn't raining. We looked out the front door. It wasn't raining. We looked to the side. It was raining in between her house and the next door neighbor's house.
Oh
Pouring down
my
rain.
gosh.
Yeah, it was just a band
So
of rain.
crazy.
It's like the clouds just opened up like this and rain just came right down. So we were literally standing outside just jumping back and forth.
Wow. Gosh, that's so strange.
So it's possible for it to happen.
I guess so. That's so crazy. Alright, I'm going to pause this for just a moment. I see a few people still writing. I want to let you guys get caught up on that. I'm going to try to be patient with you guys today because I know this is a lot to write. And, you know, if any of you don't get it all, just know you can come see me after class. I can give you this. Or this will be posted on Classroom, so you have access to this video. So pause real quick. Let's do one more. Okay, so moving down. This will be number 3. Girl. Not right. It is hot, I'll tell you that. I walked to my car and broke a sweat. Okay, so let's put a point. I'm gonna make this real crazy looking. Let's put a point right in the middle. Wow. Okay, and let's put one here and here. 3 points. Okay, a little crooked, but it'll work. My goodness, is it too dark without that? Because that's making such a shadow. I think that's better. You guys see that okay still? Yeah. Okay, I'm gonna do that then. Earlier it was so dark you couldn't even see it. I don't know what was going on. Okay, so I'm gonna write direction. Yeah. And then vertex. Axis. That's symmetry. Okay. And I'm going to write exactly what you will see on a quiz. You will get an empty parentheses for the vertex. You will have the option to circle up or down. You will have axis symmetry will already say x equals. And then your x-intercepts and y-intercepts, I think the way I have it is empty parentheses as well, but I might change that and just leave it blank so that you can decide how you want to fill those out. All right. Up or down?
Down.
Down. This thing's going down. Okay. Now, the rest of it.
Vertex is 0, 0.
Vertex. Right here, right in the middle, 0, 0. So, what's my axis of symmetry?
2, 0, -2, 0.
Oh, guys, don't think too hard about it. Remember the trick. What is the x match?
0.
The vertex, x, 0. Once you have the vertex, the first number you write is also your axis of symmetry. This will match that. 0, 0. Because, look at this. Where is this symmetrical? Right down the middle. Right there, 0. And draw it in there. Certainly doesn't hurt to write x equals 0 as well.
Yeah, 'cause that's what your
Yeah.
x-intercept's gonna be.
Yeah. Now, this one I did to kind of trick you. What is different about the x-intercepts in this problem?
They're not on the,
There's not two of them. There's just one.
yeah.
Yeah. These dots, or just to give me a guideline, okay? These are not your x-intercepts. Why are these 2 points not x-intercepts?
Because they're not on the 0 line.
They're not on the, not the 0 line, the x-axis. These do not touch the x-axis. So your x-intercept
They're 0.
is also 0. What's your y-intercept?
Your y-intercept is gonna be 0 too.
It's also 0. These are my favorite when they are all 0. Yeah. There you go. That's where it's touching. Very nice. Very nice. Okay. So. I'll let you guys get that written. What is this math used for? Excellent question. Let me Google it. Ooh, one more. I lied. You don't have to draw this one. I just want you to identify the things. So, last for real. All right. Let's do something crazy.
I'm writing it on different paper.
I don't know if this is even possible. I'm just playing with you guys now. Okay. Surely there's an equation that exists to create this graph. I don't know that equation, but, you know. So, don't shout out the answers, but you're going to determine the direction of opening, the vertex, the axis of symmetry, and the x and y intercept. So I'm going to write all of those and give myself blanks. I want you guys to fill these out on your own, and then we will review our answers together in a moment. Direction. Okay, I'm gonna pause this and give you guys a minute to work. What are these? What direction is this? Up. It's pointing up. Okay. What is my vertex?
0, -2.
0, -2. It's right here. 0, -2. Now, remember the trick for the axis of symmetry. 0. X equals 0. It's the same as the x of the vertex. Those should always be the same number. Always, always, always. Okay, now, how many x-intercepts are there? There's 2. And what are they? Good. -6 and +6. You could say -6 and +6, or, well, here, I'm going to just label them right here. You could also say -6, 0, and 6, 0. Those are your coordinates if you wanted to do it that way. And And y-intercept. 0, -2, right here. Good. Now, if you just put -2, that's fine with me. Perfect. But if you want it to be a coordinate, you would write 0, -2. Okay. Okay, guys. Oh, well, I hope so. I hope so. How do we feel? Do we feel okay? Okay. Good. This is a lot of information at the same time, but it's one of those things that, you know, the more you do it, the more you're like, oh, well, that makes sense, you know. I would love to give you guys more practice on this. I just don't have the ability to make copies today. So, I think we should take a little break. Okay, we'll take a break. Let's say come back. It's 57:07 at 2:12-ish. That would be 15 minutes. I'll write that down. And when we come back, I'm going to teach you one more thing. And then I'll give you an exit ticket after that, and I'll let you go. I'm going to see if I can try to come up with a way to copy stuff before then. So, I will see y'all in a bit. Okay, so we are back from our break. I did just give you an exit ticket, so this next little thing I'm going to show you is going to be short, sweet, real quick. I just want to introduce imaginary numbers to you. So, take a note. Imaginary, I-M-A-G-I-N-A-R-Y, imaginary numbers. Okay, so for imaginary numbers, we have a special, I don't want to call it a variable, I'm just going to call it a letter because it's not something that can change. It's always the same thing. So, imaginary numbers are represented by the letter I. And I is equal to the square root of -1. Now, if I put in my calculator the square root of any negative number, I could put 5, anything, you're going to get an error. It's going to say error, no or non-real answer. Non-real answer. That means it's not real. It does not exist. It is imaginary. Now, somebody long ago decided that they were going to give these not real numbers a name, and it is just the letter I, imaginary numbers. This is how we use it in context. Sometimes whenever you are solving a problem, you're going to end up with a negative number under the square root, like this. Whenever this happens, we use the letter I instead of solving it. Now, what on earth does that mean? I'm going to show you. An example. Let's take the square root of -36. Okay? The way to solve the square root of a negative number is to find the square root of the positive number and get rid of the negative underneath. So it sounds crazy, but it's really simple. This is all we do. Negative 36, the square root of that does not exist, because whenever we find the square root of a number, we're trying to think, what number can I multiply by itself to get negative 36? Well, I know positive 6 times positive 6 is 36. Negative 6 times negative 6 is also 36. Yes, it would have to be one negative and one positive, but then that's not the square root because it's not the same number, okay? So it doesn't exist. It doesn't exist. So what we do instead is we change this into an I with the square root of 36. And now I can solve this. What is the square root of 36? 6. Because 6 times 6 is 36. Now, if you didn't know that off the top of your head, that's okay. You could always type it in your calculator. 36, the square root is 6. So, all we would have to do is find that square root. It's 6, and we just put an I on it. And that's your answer. And I'll give you some more examples. That's all you do though. Let's say now I have the square root of negative 100. And this is what we use whenever we are solving a quadratic equation and the discriminant is negative. It puts a negative number under the square root, and I will show you some examples. So, negative 100. Well, I really can't do that. So, I'm going to just take the imaginary part out and find the square root of 100. What is the square root of 100? What is it?
5?
Not 5. 5 times 5 is 25.
Oh,
10.
okay.
10 times 10 is 100. So, 10 I. That's all you do. It sounds really scary, and it's not. What about, here, we'll do yours, the square root of negative 25. Well, I can't do the square root of a negative, so let's do the square root of the positive 25 and just stick an I outside. Okay. What's the square root of 25? 5. But since it was negative, we just put an I. That's it. That's it. Is that horrible?
No.
It's really not. It's just weird. It's uncomfortable. It's a little odd. But you know, it's not so bad. Yeah, it's uncomfortable because it's like no way can I just do it like that.
Yeah.
But you can. That's an imaginary number. Something else to know about imaginary numbers. I squared is a thing. Oh. I squared is negative 1. So these are kind of the two things to know. I is the square root of negative 1. I squared is negative 1. Okay? And the reason for this is if I have, let's see, I know that I is the square root of negative 1. So let's think of this in terms of not imaginary numbers. I know that like 6 is the square root of 36. Okay? So I know that 6 squared is 36. Notice how The 6 is like the I in this case. This is like, as I'm teaching it to you, my brain hurts a little bit. I'm not gonna lie. It's a little bit odd. I'm trying to wrap my mind around how to even explain this to you. I feel like this is gonna make it more confusing.
So would it be 6?
Would what be 6?
6 squared equals 36.
Yes, 6 squared is 36. We can also say that the square root of 36 squared is 6. Ooh, I don't like that. Ooh. I don't like that.
I think that's what I was asking.
Yeah, yes. Because we're saying that I squared is -1. Now wait a minute. No, 36. Ugh. Guys. Yeah. I don't like it either. I don't like it. Pretend I didn't show you that. Oh, just pretend I didn't. Erase it. Pretend I didn't. Okay, so let me just show you an example of where this would happen in quadratic equation. So I have an example here that I'm going to show you. Okay, so Algebra 2, Unit 1. This is like, I guess, page 3 of notes, since this was page 2, weirdly enough. I got it all out of order. Okay, day 6 notes. Continued. Okay. So, I'm going to write at the top of this imaginary numbers again. And I'll give you an example. So I have 2x squared plus 7x plus 10 equals 0. Okay. What are my values for A, B, and C?
A is 2.
Good. A is 2.
B is 7.
B is 7.
C is 10.
Good. C is 10. Okay. So, we're going to start solving this, and we're going to see how this equation is going to give me imaginary numbers. So, first we're going to find the discriminant. And remember, the discriminant is b squared minus 4ac. Okay, so what's my b again? 7. So we're going to replace b with 7 squared minus 4 times a is 2 times c is 10. Okay, so we're going to keep going. 7 squared is 49. Or, yes, 7 times 7. You got it. It's okay. And then, let's see. I think I could actually just type it in all at once, but let's not. -4 times 2 times 10. I didn't mean to hit plus. -80. -80. So, do I write plus 80 or minus 80? Minus 80. Okay. So, now 49 minus 80 Sure enough, I get a negative number. Negative 31. So my discriminant is negative 31. Okay, so when I put this into the quadratic formula, remember, x equals negative b plus or minus the square root of the discriminant all over 2 times a. Let's start plugging stuff in. X equals negative 7 plus or minus the square root of negative 31 all over 2 times 2a. Okay, and I know I'm running through this quick, but I'm really just wanting to kind of show it to you. And you can tell me to slow down if you need me to. Okay, so at this point, here's what we would do. I'm gonna draw an arrow and kind of start over the next line. I have x equals positive 7 becomes negative 7 plus or minus. Now, I have the square root of negative 31. I cannot do that. You cannot find the square root of a negative number. If I tried, this is what would happen. Same thing as last time. Second square root, negative 31. It's not. We're going to get a decimal, and that's okay. So it's going to tell me a non-real answer. It's not going to work. So here's what we got to do. Instead of negative 31 under the square root, we're going to put an I with 31. I know. It's funky. And then 2 times 2 is 4. Okay. So all I did is I took this and put an I outside. That's all I did. Okay. So now I could just leave it like this and be done, because I can't go any further because I have an imaginary number. If I wanted to, though, I could find the square root of positive 31, and I would get 5.5756. Okay, so this is the only thing I can do to go further. Negative 7 plus or minus. I'm going to go with 5.57i over 4. And because there is an imaginary number, it's like, you treat it like a variable. Negative 7 and 5.57i, are these like terms? Do they both have an I? No, so I can't add them together. That's as far as we can go. Nope, you can't add them or subtract them. So, as uncomfortable as it is, that's your answer. Very uncomfortable.
Yeah, I was just gonna say, I really don't like that.
Yeah, it's super uncomfortable. I don't like it either.
I feel right.
It sure doesn't. It really doesn't. Nobody that I've ever shown this to has been a fan. Not very fun. But, you know, it exists, I suppose. Yeah. So there's your dose of imaginary numbers. Basically, if there's a negative under the square root, get rid of the negative, write I instead. That's it. That's it. Because it doesn't exist. Okay. Well, I'm happy to show more examples of this, but honestly, it's not something I'm going to test you over. Just wanted to let you know that it does exist and you may see it one day in the future, especially if you're deciding to pursue a math career. Don't know that any of you are, but if you decide, it exists. But yeah, that's really it, guys. If you are still working on that exit ticket, feel free to keep working. And I'm happy to check that before you go. But that is all. You're free. Be free. Let your brains rest. That was a lot.